Morning, everyone. My name is Lena Nance, and this is Alex Hoyos, and we had the pleasure of working with Semiconductor on their Team WEBONICS project. Predominantly this year, we focused on using a web-based environment to simulate automotive buck converters. Since Infineon discussed how their buck converters already work, we can dive right in. Who is Semiconductor? Semiconductor is an international multi-billion-dollar corporation that deals with innovating, effective, and efficient semiconducting devices. As one of the world's leading semiconductor distributors, they have a portfolio that consists of power supplies, logic gates, sensors, and so much more. They service industries such as the automotive industry, which generates just over 30% of their revenue, as well as other technologically based companies like communications, computing, medical, and aerospace sectors. Our project in particular had a lot to do with marketing and sales, but before we go into the specifics of that, let's take a look at the status quo of Semiconductor's shopping environment. As it stands right now, a customer must navigate a web page of multiple menus, download a SPICE simulator, and then import a netlist, run simulations, and then send their results back to Semiconductor, who will then verify it. Whereas this no doubt demonstrates Semiconductor's extremely good customer service skills and response time, it has a lot to be desired and it's not always seamless. For that reason, we see that the motivation behind our project, where we come in, is to solve interfacing issues between the customer and the producer. We want to shorten the time it takes to order products and shop for semiconductors, as well as minimize points of failure and demonstrate these products in the best light possible. With that said, I'm going to hand it over to Alex, who's going to talk about our project.
So, with that being said, the implications for the company is that by streamlining this process, we're going to solve interfacing errors. This, with time, is going to drive sales and customer satisfaction. Now, the question is, how is Semiconductor going to tackle these issues? So, Semiconductor is teaming up with Mentor Graphics. Mentor Graphics has this online simulation called System Vision. Semiconductor believes that by implementing simulations online of their products, customers can go online and simply decide if this is the product that they need. So now, where does our team come into play? Well, Lena and I focus in simulating a family of step-down regulators, DC to DC converters. You can see them on the left side. We created a simulation for 5 of them for the automotive industry. And on the right side, you can see some of the paint simulations we did. We have them separate, so we can do some tests with them due to non-ideal cases. So for accomplishments for this project, at least for phase 1, we simulated our first buck converter. This was simulated using VHDL, the foundation of System Vision, and circuit analysis. As you can see on the screen, we have a simulation of the bench test of the circuit. This is what customers will be looking into. They will be able to modify the values of the passive elements of the circuit to see the output, and if it's something that they like, that will drive them to purchase the product easier and efficiently. Another accomplishment for this project was simulating the non-ideal pins. For example, this is one of the pins of the product of the NCB A9104. This is a frequency modulation. Now, integrating this frequency modulation using VHDL is a little more complicated, since this is a non-ideal device, semiconductors. So, for example, in this case, we have a frequency that modulates, and this frequency is chosen based on the type of resistance you put in the element in the input pin. So, for our case, I run a sweep of the resistance, and I get a sweep of the frequency output. And we can also see that the data shows a decaying exponential function, hence a non-ideal case. This in turn not only slows down simulation too, but makes it more difficult to code in VHDL. So another accomplishment was reducing the simulation time of such things. Semiconductor wants to make sure that if we're able to simulate this online, it should be rather quickly. So in the beginning, our first simulation lasted about 20 minutes. We wanted to go down to 5 minutes per 1.5 milliseconds in simulation. Now, it may not sound like much, but when you're switching at 2 megahertz, you get a reasonable amount of transient. So now Lena's going to talk to you about phase 2 of these accomplishments.
Now, in the spirit of marketing, our team also designed a printed circuit board that's a more tactile component to the simulations that we just ran on System Vision's website. We used schematics to generate basically instances of all 5 of those family of buck converters, the NCD 8901. Here we have the basic PCB block diagram, and in it has 3 cases with 3 different buck converting chips that take a 6 volt to 30 volt input and step it down to a 5 volt output via a USB jack, which can then be used to power, say, a cell phone. And this demonstrates the product's capability in the field, whereas it would normally use your car battery to power things like your console in your car, for instance, or even charge your cell phone inside your car. So these actually worked on our PCB, which was nice. And then we also are demonstrating the power of this chip to synchronize with other chips. Normally it's asynchronous, but you can still use other timers with it, and it just demonstrates a little bit more of the versatility. And the last section of this block shows the efficiency of the chip, because it has an output current and voltage that you can also use to extrapolate the power consumption. And as you see on the right, here's just on your left. They're right now, sorry. You're right. It's the path layout of part of our design. So in total, we were able to achieve our best outcome by simulating all 5 of the buck converters that we were given, as well as printing and designing a PCB board that can be taken to various recruiting events and industry fairs. Thank you so much. I'm going to hand this back to Alex.
And finally, we just want to say thank you to everybody that supported us. That includes Robert Davis, Frank Olenko, and David Hooper. And a special thanks to also Dr. Suna for allowing us to be in this project.